Oh, there we go. Now we have sound. Okay. Maybe I should. Yeah, okay, looks okay. Right, now let's see where we left off. Um, okay. We are here, isn't it? Yeah, okay. Okay, so let's see now. The holding type 2 equation described by that formula, where x is the amount of prey available, and A is the maximum consumption rate of the predator. Okay, graph. Okay, so let's make this function. A is 0.5, and then n is 5. Okay, let's have a look at the graph. Okay, there we go. What are the difference between the, well, one obvious difference is the graph appears to level off. Okay, take the first derivative and interpret the physical meaning. Okay, well, the first derivative, no problem. So that's it there. Well, the answer is the same as 171b. Yeah. So, yeah, it's, I guess, maybe not quite the same. The following problem deals with the type 1, 2, and 3 equations. These equations describe the ecological event of growth of a predator population given the amount of prey available for consumption. So it's a population, right? Take the first derivative. Okay, so it's the rate of change in the population size, right? Isn't that it? Show that fn equals a half a and interpret the meaning of the parameter n. So we are taking n as 5 still. So f5, that is a half a, because a is a half, yeah. So, okay, so the interpretation, yeah, okay. So we just go back to what the A means. A is the rate at which the predator meets the prey. So this would be the and what's X again now? X is the amount of prey. So the amount of prey needed so that there is a 50% encounter rate. Find and interpret the meaning of the second derivative. Okay, so let's differentiate this again. Okay, I'm just curious to the graph of it. Okay, yeah. Interesting. Okay, that's it's negative. It's always negative. So it's the same deal as before. The second derivative is always negative, meaning the growth rate of the population is reducing. Okay. Then we have 173. Okay, let's type in f of x is a 0.5x squared over n squared, which is 5 plus x squared. So let's graph it. Interesting. Derivative. Okay. Yeah, well, this one, it appears to be, does it level off, I wonder? Yeah, it does appear to level off. It appears to reach a maximum value, i.e. a natural limit on the population size. Sure does look like it. Sure does look like it, yeah. Take the first derivative and interpret the meaning. Yeah, find and interpret the meaning of the second derivative. Okay, so the second derivative. Okay, I want to graph it. Interesting. Second derivative is positive and then negative. So there's a increase and decrease in the rate of growth, the rate at which the growth changes. Yeah. Interesting. So at small values of x, the rate of change in f of x is increasing. But beyond a certain value in x, the rate of change in f of x will decrease. A limiting effect kicks in and causes the population to level off. Don't know. Let's see. 173. So, oh, well, why did they give us the N and the A if the answers don't have it in it? When the amount of prey is extremely small, the rate at which the predator grows is increasing. But when the amount of prey reaches above a certain threshold, it begins to decrease. That's what I said. At lower levels of prey, the prey is more easily able to avoid detection by the predator, so fewer prey individuals are consumed, resulting in less predatory growth. Okay. Yeah, I think I would not have gotten that myself, to be honest. To be perfectly honest. What additional ecological phenomenon does that describe? Yeah, to be honest, I wouldn't have got that. I would not have got that. Part D, I would not have gotten part D. I would just be guessing at what is happening in nature. Okay. Right. The population of snowshoe hare in thousands and lynx in hundreds is collected over 7 years. Okay, here we go here. Graph the data point. Okay, so we need to open up spreadsheet here. Graph the data points and determine which holding type function fits the data best. Oh, interesting. For both. Graph the data points and determine. Oh, one of them is the hare is the prey, I'm guessing. So that's the X, isn't it? So that's the X and that's the FX. So yeah, okay. That's the X and that's the FX. Okay, 20, 55, 65, 95, 10, 15, 55, and 60. Okay, so this is the hare population in thousands, and then the lynx population in hundreds. Now, I'm going to convert that to thousands just so we're on the same scale. No, I've done that wrong now. I need to be careful. That's the lynx population in hundreds. So what I mean to do is convert this into hundreds instead of thousands. So this has to get bigger. Because I don't. In fact, you know what? Maybe I'll just put the full number in. Maybe I will. Want to avoid any problems here. Be safe. Okay, let's scatter plot. Lynx versus hare population, I guess. Number of hares, number of lynxes. Yeah, okay, so not a lot of points here, but which one's it gonna be? Well, not the linear one, so we'll just forget about that one. It's I think the last one would be reasonable. It's leveling off. Let me just draw again this one, x over 1 plus x, I'll just say. Could be that one. X squared over 1 plus x squared. The difference between being initially concave or convex, huh? Yeah, I'm kind of leaning more towards. Really don't know. I'm gonna go with the last one. That's only 4 data points, so it's really a bit silly to be stressing about it. Use the meaning of the parameters a and n. Determine the values for those parameters by examining the graph of the data. Recall that n measures when the prey value results in half the maximum of the predator value. Okay. This is a bit tricky. Use the means the parameters a and n, determine values for those parameters by examining a graph of data. Recall that n measures what prey values results in half the maximum predators. So how many prey until you get half the maximum predators? So 3,000. So we're going to have to be doing a bit of estimating here. Yeah. What's the average here? So I'm going to say A is going to be roughly between these two, but not exactly. What will I do? Okay. I'm going to try and fit in here just a straight line. Linear show equation. And maybe actually, yeah, I should insert trend line. I should do linear, but I should force it through the origin, I think, and show the equation. Okay. So it's not perfect, but it gives me an A at least. So I can see that the A is 0.06 roughly. 6. I feel like too many decimal places would be a bit misleading. I'll just say 6.2. Okay, that's the A using the first formula. Yeah. Now, what else does it say? But N measures what prey values results in half the maximum predators. So maximum predators looks like 6,000. So the question is, that's X. That's N. When would N equal? Oh, didn't we have the formula earlier? When will N be a half of A? No, that's not great. We'll call that N measures what prey value results in the half maximum. So is that when you get, I'm not really sure to be honest, is that when you get 3,000? N would be 3,000 divided by that? Let's say 48,000? 48,000? I don't know, I think I've done something wrong there. Recall that N measures what prey value results. Oh, prey value. Recall that N measures what prey value. So the prey value is the hare. So that's the X. Results in the half maximum, the predator. Yeah, no, that's right. 3,000. So that means n we think will be about 48,000. Does that look right? Yeah, that looks about right. Okay. All right. So now plot the graphs and which one looks most correct. Oh, okay. I can't. Okay, let's try this one. So, okay, we've got tree to plot. So I'll just define A as being roughly 0.062 and N as being roughly 48,000. And then our first graph is just a simple AX, and then our second graph is AX over N plus X. Then our last graph is AX squared over N squared plus X squared. Okay. Plot, 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 and we can go up to a large number here. We need to get up to 6,000. Okay, and then to 95. Ooh, maybe. Okay. Did these not even show up? Oh, there it is. Huh. The A and the N is way off. I feel like I've done something wrong with the N though. I don't feel like I've done that right. Sorry. I really think that's wrong. I must be misinterpreting it. Recall that N measures what prey value results in the half maximum of the predator. You know, I feel like they don't say it in the question. But I don't think it's precisely clear what the fx is, at least not to me. So let me just quick Google. Yeah, it's a density. The density. So like here, it says determine the where's it gone here? Here it says recall that n measures what prey value results in the half maximum of the predator value, but it's a density, not an absolute number. So that's why I was a bit confused why this is a half A. So really these should not be going beyond 1, I think. I'm really confused by this question, to be honest. So maybe I should change this now. Well, it's going to be a half A. So just in this case, it's just going to be 0.5. So let me draw this again. In the linear case, anyways. Yeah. you know, I really am not satisfied with this last question because it's not I'm not clear in my head what the x and the fx are. Can they only be between 0 and 1? If so, I should change these numbers. Um, doesn't really say what these. See, I think that there's densities involved here that's not being captured. So like x, the amount of prey available, and a more than 0 is the rate at which the predator meets the prey. I feel like these should be all rescaled so that it's for our total of 1. Let's have a look at the answer at the back. No, it's not. It's they have absolute numbers here. Man, I just don't know. I just don't know. I've gone way over time. I expected this to be quick. Graph the data points and determine which. Yeah, I don't know. I don't know. I think I'm just gonna leave it. I mean, I tried to find an A, tried to find an N, and if I look at the graphs, yeah, the best one is still the last one, but I've only had 4 points as well. I think I'm going to a plot with 4 points. No. And I'm not exactly clear on the x and the fx because I think there's a density involved in it here. And the question's very unclear to me. I don't particularly have a biology interest, but A is the maximum consumption rate. Yeah, so that's definitely, should that be less than 1? Or it's prey consumed per predator? Really bad. I'm really confused by this last page. Holding equations. Yeah. Might have to read up on it, but I dislike the idea of having to do some biology reading to solve this problem. So I'll just throw my hands up and say I'm moving on.